Hello everyone, welcome to PYQ'S. This is IS 2014 question on Naiver Stokes Equation for steady laminar flow of viscous incompressible fluid between two infinite parallel plates. So Naiver Stokes Equation is mentioned in syllabus, but from 2014 to 2019, only one question in 2014 is asked. So in 2020 and onwards, we have this topic to be asked. It is a potential topic. So now we will try to solve this question. So first of all, what Naiver Stokes equation is? Naiver Stokes equation is generally F equals to ma, that is Newton's second law of motion. The formulation is based on this, F equals to ma. It is second order non-linear partial differential equation. So it is given by rho dq by dt equals to rho b minus differential of pressure term plus mu del square q. Rho is the density, q is velocity, b is force term, rho is again density, p is the pressure, mu is coefficient of viscosity, and q is velocity. So this is the equation of Naiver Stokes. Now we'll go for solving the equation. It is given that steady flow means del by del t equals to 0. It is laminar flow. Suppose in x direction it is laminar flow, then velocity in x direction is not changing. X direction is not changing. So it implies del by del x equals to 0. Now let these two are infinite plates and this is the center line. Okay. So here y equals to 0. Suppose this is y direction, this is x direction, this is x direction. Now y equals to minus h, and it is y equals to plus h, and this is y equals to minus h. Consider the x direction velocity is u, and g, it is a vertical plate, so g will be the force. Now here you can write these two conditions are there. A third condition will be the boundary condition. Boundary condition, that is u x plus minus h is equals to 0, because there is no slip. No slip. It is no slip condition. And now third is, that is b. Here it is given b. b is minus j cap. Now using the Naiver Stokes equation, we will apply Naiver Stokes equation in two directions, y direction and x direction, and then we will try to find out the velocity profiles. So velocity and pressure profiles. So in y direction, velocity is 0, that is dq by dt is equals to 0, and b is minus rho g. So I'll write equation here again. Let me write this Naiver Stokes equation here. Rho del q by del t equals to rho b minus delta p del p into del square q. This is Naiver Stokes equation. We'll use this. So here it is minus rho b minus del p by del y, and there is no coefficient of viscosity because it is given here. So now for solving this, I'll get del p by del y equals to rho g. There is no viscosity in y direction, so mu is equals to 0 in y direction. Now integrating with respect to y partially, I'll get p equals to, this is minus rho g y plus fx, some function of x, but hydrostatic distribution of pressure is in y direction, so this is equals to 0. You can write hydrostatic distribution of pressure distribution of pressure, just a minute, distribution of pressure in y direction. So Fx equals to 0, then y equals to, we got this. Now applying in x direction. Important is application in x direction. So for x direction, we have again, it is equals to 0, there is no acceleration because laminar flow. And then rho, there is no gx here, so this is 0, minus del p by del x and plus mu. Suppose q in x direction velocity is u, then del 2u by del y 2. See, the question says laminar flow, viscous incompressible flow. Viscous incompressible flow. So there is viscosity in y direction, in x direction. So this is the equation. Now to solve this, we have del 2u. U is y x component of velocity. Mu equals to del p by del x. So this can be written as del 2u by del y2 equals to 1 by mu del p by del x. Now integrating twice, we will get u equals to, when we will integrate one time, I will get here y, and then again integrate, I will get y square by 2. So y square by 2 mu del p by del x plus one constant c1y plus c2y. This will be the velocity in x direction. Now applying boundary condition. Applying boundary condition. Boundary condition is ux plus minus h equals to 0. So when first ux plus h equals to 0, I'll get 0 equals to 1 by 2 mu, 1 by 2 mu del p by del x into h square plus c1h plus c2. Now when u equals to h comma minus h equals to 0, then u equals to 1 by 2 mu, again the same thing, del p by del x into h square minus c1h plus c2. You can see this adding both, this will be cancelled out and I'll get c2 equals to minus 1 by 2 mu del p by del x into h square, and c1 is equals to 0. So these two are the constant. Now from equation this first and adding this second, we'll get u equals to 1 by 2 mu del p by del x y square minus h square. So that will be the velocity profile in x direction, which depends upon y. So from Naiver Stokes equation, what we find out? We find out that this will be the velocity profile. Now, if we draw the velocity profile here, it is x direction, it is y direction. So we have this is origin. So velocity profile from minus h plus h to minus h will look like this. It will start from 0 and end at 0 and will be maximum at center line. So this will be going like this, a parabolic curve. So sorry, this is not parabola, this is like parabola. So this is one line only. This will be the velocity profile required. This will be the velocity profile required. You can write this is velocity profile, and which is maximum at center line. Maximum at center line, that is h equals to 0. So that is all we need to find out using Naiver Stokes equation. That is all in this lecture. Thank you.